All right, so let's talk about those two special cases that we've come up with. The first one is when you have an absolute value that is equal to 0. So equal to 0. Here's the question. The question is, where are you 0 units for 0? And that is only at one spot when you are on 0. So this is one special case where there is only one solution, and it's when that absolute value is equal to 0. So when it is equal to 0, we just solve like normal. Minus 14, minus 14. So I get 5x equals negative 14. So x is negative 14 over 5. Okay. So special case, one answer. Okay. So most absolute values have two answers. Special case number 1 only has one answer. Special case number 2, here's what I want you to think about. Absolute value is equal to negative 8. This one, I hope that you're all thinking it in your head, has no answers. We cannot be negative units from 0. So this one is a no solution. You don't even have to do any work. Okay? We have an absolute value equaling a negative number. No solution. Okay? All right, so let's talk about, and we just mentioned this earlier, that we have what the definition of absolute value is. I skipped too far ahead. So the definition of absolute value is distance from 0. Okay, so when we think about inequalities, we're going to think about these the same way. We're going to think about how far am I from 0. So go ahead and draw me on your paper 2 number lines. And we know from the equations that we are going to have a 3 and a negative 3. Okay, we know that from the equations. The question is when we have inequalities, there has to be a shade. Okay? So here's the question for you to ask yourself. If you are, this means, switch the pen back on, greater. Okay, if you are greater than 3 units from 0, where are you? So open dots. More than 3 units from 0 means we are farther from 0, so we are here. We are out here on the edges. Okay, so going back to what we did at the very beginning, interval notation for this answer will be negative infinity to negative 3 union 3 to infinity. Here's what I want you to think of. This is called an OR statement. Greater is an OR. 2 shades on the number line, 2 inequalities when we go to interval notation. Okay? 2 and 2. Greater is an OR. 2 inequalities, 2 shades. Okay? The next one is less than. Less than is an AND statement. Still open circles, but less than is an AND, 1 inequality, 1 shade. So our shade is going to be right here in the middle. And when we write our interval notation, we're going to go from negative 3 to positive 3. Now, to close those dots up, all we have to do is have a less than or an equal to underneath. So here's what I mean by that. If this original equation had an equal to right there, then our dots would close up. I'm not going to close them up, okay? So let's look at some special cases, and then we're going to dive into a few examples. Okay, so special case number 1, absolute value of x equals 0. That's still a one solution answer. And the one solution answer is when x equals 0. Okay, one solution answer. Absolute value of x is less than negative 3. Well, we know absolute values are greater than or equal to 0. So can it be less than negative 3? No, no solution here. Okay, I cannot have answers that are less than -3. That makes them more negative. No solution. Okay, the last one, x is greater than -3. Well, I know that absolute value has to be greater than negatives, so this one is actually all real numbers. All real numbers. Okay, so same rules apply. We're going to isolate the absolute value, split into two parts, solve for x. We're going to graph it if it's an inequality, graph our solution, and we're also going to write it in interval notation. Okay, so let's look at a few examples. So same steps as before. So let's look at a, and if you need to pause, if you want to write the steps down, you can pause and write those down. So let's look at a couple of examples. I'm going to do 2 with you, and then you're going to do 2 by yourself. Okay? So first one, is the absolute value isolated? Yes, it is. Okay? So what I want you to think about is we are going to now split our equation into 2 parts. -4q plus 2 is less than or equal to -10. And then the other part is -4q plus 2 is greater than or equal to +10. So one equation looks one inequality looks exactly like the beginning one without the absolute value. The other one is the negative. So when I make it negative, I have to flip the sign as well. Okay? So now all we're going to do is solve. -2 minus 2, -4q is less than or equal to -12. And then I hope you remember the rules. If I divide by negative, you should remember them. We went over them yesterday. Q is going to be greater than or equal to 3. Okay. Now if we do the other side, steps are going to be the same. So -2 minus 2. -4q is greater than or equal to 8. Divide by -4. Divide by -4. Q is less than or equal to -2. So if I think about this on my number line and on your homework sheet, the number lines are already drawn for you, so you don't have to worry about drawing them. We should have, because of our equal to's, close dots, and then we should have shades. Where are we less than -2? That's this way. Here. Where are we greater than +3? That's this way. So then my final solution is -infinity to -2 bracket union bracket 3 to infinity. Okay, so a little bit more steps on these guys. A little bit more steps. Let's look at B. I'm going to give you just 30 seconds if you need to finish writing down anything. All right, so some of you, I bet, have already started B. So first step is to add 3, add 3. Absolute value 0.5r is greater than or equal to 0. Okay, you should, red flag. You should be red flag in your brain, bells going off, whistles going off, all kind of stuff, okay? Where is an absolute value greater than or equal to 3? Everywhere. That's the definition. This one is all real numbers. All real numbers, okay? All right, even if you solve it, we're never going, when you see a 0 right there, your red flag should be going off. And I bet some of y'all like just barreled right ahead and got 2 answers. No, all real solutions for this one when you see a 0 with an absolute value, okay? All right, I'm going to stop the video because my time is about to run out. You're going to do the last 2, and then you're going to click on the last video recording to check your solutions.